Remember, so only one aspect of identity has been touched. Even that one, we've not really touched it fully. But I have opportunity of laying my hand into some questions, and I realized that those questions require the in-depth knowledge of the various factorization techniques which we have above. And as a result, it will be important we quickly go over all these factorization techniques so that we'll be able to master our identities thoroughly as it is supposed to be done. So I will quickly make mention of factorization techniques that we need to learn. Then I will bring an example or two examples from each category. All right. The first one is what we know as the general factorization technique. That one is the usual factorization that we have from GSS3 level up till senior classes in the Nigerian secondary school. So I don't believe we should have issue with that, though we are still going to solve one or two questions on that. Now the next one is another factorization techniques that we call or we refer to as Sophie Jamin. So this word Sophie Jamin is the name of a mathematician. I think a French mathematician is the one who bears this name. So he is the one, she's the one rather, because this mathematician happens to be a female. She's the one who came up with the idea of how can expression of this form x raised to power 4 plus 4y raised to power 4 can be solved. So when we have expression of this form, how do we solve it? So we realize that our basic factorization techniques which we learn either from GSS3 up till the senior classes in secondary school will not give us opportunity of being able to solve this. So in order to solve this, we have to learn what is known or termed the Sophie-Germain identity or Sophie-Germain factorization. So that is that as per the Sophie-Germain. The other one is SFFT. So this is the full meaning of the SFFT. It means Simon's favorite factorization trick, or we can say Simon's favorite factorization technique. So this one is another approach, right, by which another form of expression can be dealt with. So when expression is of this type, AB, let me say 3AB plus A, let me say plus 2A plus 3B is equal to 0. When we have expression of this form, right, so the only way by which this can be done is not by this approach and not by Sophie-Germain approach, but rather by what? By the SFFT, right? So it shows that when we have expression of this form, so it is possible we break algebraic expression given to us into this level. When we get to this level, we won't be able to progress with the solution, except that what? We apply the appropriate factorization technique that can be used in dealing with questions of this type. So as a result, so it is also important we learn that factorization trick or factorization technique. Then lastly, we have what is known as the splitting factorization technique. This one as well is used when we have expression of this form, x raised to power 4 plus x raised to power 2 plus 1 is equal to 0. So when we have any expression or any equation of this pattern, any equation of this form, so the best approach by which it can be addressed is by what we know as what? Splitting factorization technique. Now, at times, the question we want to solve may not come directly in this form, right? But by the time we try to adjust the question, right, or the expression which we are dealing with, so if it leads us into something of this nature, then we can continue solving such a question by what? The splitting factorization technique. So we are now going to deal with each of these factorization techniques which we have here with examples. Now, I am going to start with our usual factorization that we all know, which we started learning right from GSS3. So it is possible when we break down the given expression, so So it leads into this form, something of this type, s squared plus 5s plus 6. So we know in order to deal with this thing, so it has to be factorized quadratically. So factorizing it quadratically means I'll be interested in the coefficient of the first term and the last term, right? So what I will do in that case is to say that the number I have here multiplied by the last term. So we know that is 6. Now we now want to think of various factors of 6 we know can yield what we have at the middle here, 5, right? And we know very well that factors of 6 that exist are either 1 times 6 or 2 times 3, right? So which of these two can I combine to obtain plus 5? Though, when we observe these two factors, I think any of the two can be used. So we can go for any one we prefer. But in my own case, I will love using this one. So in that case, to solving this thing, I'm simply going to rewrite it by saying that s squared plus, now this mid value, this mid term rather, will be substituted with what I have here. That is, so that 5 will be written now as 2x plus 3x, then finally to the last term we'll say plus 6. So that is, we want to break down this mid term into factors of what? Of multiplying first term and the last term. So that is 2 and 3, and we know how do I combine 2 and 3 to get plus 5? That's by calling it plus 2 plus 3. And since the term we have at the middle contain letter x, then x also has to be there. So in order to continue with this thing means we are going to group what we have here. So x squared, now grouping it here can be something of this type, x squared plus 2x. So let's say we group them together like this, and 3x plus 6 will also have to do what? To be grouped together. So in order to continue with this thing, so we want to look for what is common to elements I have, or all the items I have in my first bracket, and we can see x is present here and here. So meaning x into, here we have x left, so that will be x plus 2. And then plus, also in this second bracket, I'm also interested in what is common to the two items in that bracket, and we can see that is 3. For the sake of those in junior secondary classes that might not have really done this thing, so this 3x here means 3 times x, while this 6 here means 3 times 2. So we can say 3 is common. So once 3 is common, so we are going to have it outside the bracket. And what do we have left? So we are left with x plus 2. We must manipulate or adjust this in such a way that the same item is in the two brackets. That is, in this bracket and this bracket, so they are alike. They look alike. In position where this one has addition, this one must have addition. If it is minus we have here, it is also minus we must have here. So from this corner, we also look for what is common to them again. So you can see x plus 2 is here, x plus 2 is as well here. So therefore, I will write out my x plus 2. I can write out my common factor first. And what do I have left? So what I have left is this x and this plus 3. So I will now say bracket x plus 3. And this x plus 2 into x plus 3 is what? The solution to factorizing x squared plus 5x plus 6. Now let's move over to the next question. Still under the first category of factorization techniques that we want to talk about today. That one is still applicable to our general or normal factorization. So the question I have this time around is this. I'm asked to factorize x squared minus 7x plus 12. So that's the next item that I want to deal with, or the expression I want to deal with. So the same reasoning. What do we do here is this. We need the coefficient of the first as the last term. So what do we do with those two? We multiply coefficient, that is the number we have before this square, by the last term. 1 times 12 there gives 12. Now, what happens to the 12? We want to examine various factors of 12. So remember, factors of 12 are those two numbers we can multiply together to get 12. So that can be 12 and 1, it can be 3 and 4, it can be 6 and 2. That by combining any of these three factors that we have, how can I combine it in such a way that it will give -7? So you can see this combination of 12 and 1. So now we combine either by means of addition or by means of subtraction, and we know no miracle can be performed either by adding, by subtracting in such a way that 12 and 1 becomes -7. We know this one is no good area, it will not work. Let's also try this last one, 6 and 2. There is no any means we can use to combine 6 and 2 by way of adding or by way of subtracting, right? So that it will yield -7. We know this one too is no go area. Now let's see the mid one. So 3 and 4, there is a means by which I can combine 3 and 4 to yield or to give what? -7. So the way to do that is to say this is -3 and this is what? -4. Now, having gotten this, we will now use this one in place of what? My mid term. Since this combination yields -7, then it shows that what? And actually what we really want to do is that this term which we have at the middle, we want to break it down into two parts, such that those two combinations, right, will give rise to what? The result of multiplying coefficient of s squared and the last term. So which means I'm going to use -3 and -4. So to continue with this means I will write s squared minus 3x minus 4x plus 12, right? Then what follows is I'm going to group it now. I will group it in this way. Now, after grouping it, I will also look for what is common to what? To those two brackets. So I can see x is here, x is here. Also, for the sake of those in junior classes, x squared there means x times x. Why this 3x here means 3 times x. And since we are interested in what is common, we can see x is common. So I will write my x, then every other items that still remain will now be kept in this bracket. Now, in the first part of the first bracket, what do we have left? We can see it is x since we have kept this one. What we have left is x. So here I'm going to say x, then followed by the sign. Then the second part of the first bracket, what do we have left? So let's come back to this place. You can see the number which we are yet to touch is 3. So meaning I will put my 3 here, then followed by minus. Right? I'm also interested in finding what is common to 4x and 12. So doing that means I can expand that 4x there may mean 4 times x, while 12 there will be written as 4 times 3. So we can see 4 is common to the 2. So I will keep my 4 outside. And what do I have left? In the first part of the second bracket, we can see it is x. Then minus. What do we have here left? -3. Right? Remember I said the other time that in the process of doing this, this factoring, we must ensure that exactly what we have in the first bracket is exactly what we have in the second bracket. And the only way for this one to resemble this is we have minus here. But is it different from what I have? It is not different. If I try to open this second bracket, we realize that we'll get exactly what we have here. So with this, we can also look for what is common again. We can see x minus 3 is here, x minus 3 is here. So I can keep that one here, x minus 3. Then what do I have left? This x outside here, and minus 4 here, minus 4. So this one is what? The solution to the second question on our general or on our normal factorization technique. All right, let's take one more question on this. So, and that is factorize 4x squared plus 2x minus 6. So this is what we want to factorize now. So we apply the same concept. So what is the concept? We need the coefficient of x squared as well as the last term. So 4 multiplied by minus 6, that gives minus 24. Or we can do without that minus. Let's just say 4 times 6 here gives what? 24. Now, then the next thing is I need factor solve the result of my multiplication. So result of my multiplication is 4 times 6, that is 24, right? So I need factors of 24. That is, what are those two numbers we can multiply together that will yield or give 24? We know it can be 24 and 1. It can be 12 and 2. It can be 6 and 4. It as well can be 8 and 3. I think this is all regarding factors of what? 24. But my interest in all these factors is I need any two combination here. Any combination here that can give me plus 2. So how can I combine? Is it this and this that will give plus 2? Or this and this, or this and this, or this and this? So without wasting our time, so when we go through everything we have here, we can see that it's only this combination that can give rise to plus 2. And that is by saying plus 6 minus 4. So that plus 6 minus 4 will now be used in what? In replacing this mid term. So to doing this now, I'm going to say 4x squared, right? Since we said we are using plus 6 minus 4, that becomes plus 6x minus 4x minus 6. Now the next thing is we're going to group this and this, this and this. And the essence of this grouping is we want to look out for what is common to this and this. Remember the first one, we have 4x squared. So I can break that one to 2 times 2 times x times x. The other one is 6x. That one can be broken down into 2 times 3 times x. So we can say 2 is here, x is here. So it shows that to this first bracket, 2x is the common factor. So what do we have left? We can see in the first one, what we have left is 2 and x. So here, that will be 2x plus. And below here, what I have left is 3. So that will be 2x plus 3. Then minus. So I will also have to do the same thing. What is 4x? So 4x can be written as 2 times 2 times x. And 6 I have here can as well be written as 2 times 3. So what is common to the 2? The upper and the lower one, we can see it is 2. So I will have my 2 here. So what do I have left? In the upper part, I'm left with 2x. And remember, we are using this sign. So it's going to be plus. And what do I have left below? It is 3. So 2x plus 3. So reason for having this in as plus is when we try to open this bracket, it surely will give the result which we have here. So to conclude now, we also look for what is common to the two terms again, right? We can see 2x plus 3 is here, 2x plus 3 is here. So we extract that one out. So we say 2x plus 3 against, what do we have left? I have 2x and minus 2 into 2x minus 2. And that is the solution to the third question. So those are the little questions we are going to talk about under our general factorization techniques or general way of doing quadratic equation or quadratic expressions factorization. So let's quickly copy this so that we can move over to another aspect of factorization. All right, so the other aspects we want to talk about is what is known as self-germane. And whenever we have expression of this form, x raised to the power 4 plus 4y raised to the power 4, right? Now we can see that this thing can't be factorized the way we carried out the first 3 types of factorization that we did. So So dealing with this type of expression, the concept of suffix germane as was founded by suffix germane is what we must apply. Now, so in order to deal with this thing, right, we are going to make it very simple. So what do I mean by making it very simple? We can see the power of 4 is too complex, right? So we rather reduce this power of 4 to something of this nature. So this thing, I will rewrite it as, I can write x raised to power 4 as x raised to power 2 squared, right? Then followed by plus. So what I have here can as well be changed to 2 raised to power 2 y raised to power 2. Y raised to power 2. And since 2 is common to this and this, so it means we can write this thing as x squared raised to power 2 plus 2y everything raised to power 2. So that's the first thing. So it is this thing we are now going to solve. So when we solve this thing now, so it will now give us the result of what? Of factorizing this thing. Now, from here now, identity will have to be applied. Then the next thing now is to think of what identity do we think we can use. So we know that out of the 3 identities we have talked about in this level, so we realize that we have a case of a squared plus b squared. So what we have here is of this pattern, or let me say it follows this structure. So when we have an expression of this structure, right? So what is its equivalence, right? So what is its equivalence? And we know that when we check those lists of identities, so let me quickly do the short recap of it. The first one there, I said a plus b squared is equal to a squared plus b squared plus 2ab. We also have a minus b squared, which is a squared plus b squared minus 2ab. And lastly, we have a squared minus b squared, which is a minus b into a plus b, right? And let's look at what we are solving, right? This thing is of this pattern. So the first item squared, second item squared. Now let us check number 1, 2, and 3. Do we have any identity that exactly means a squared plus b squared? So we can see such is not present. So what we will now do is we will derive this thing. We can derive this thing. And how do we derive a squared plus b squared? We can come into this first one, right? Now remember, since what I'm doing contains plus, it is the one that has addition that I will pick. Because when I check the second one, I also have a square plus b square, so as not to make a mistake of saying, okay, since a plus b square is present here and a plus b square is present here, that I can go with any of the two. We cannot go with any of the two. It's only the first one we can go with. The reason is this thing we have here is generated, right, from one known identity. So since this thing contains addition sign, so it has to be identity whose element contain plus. And we can see it's only this one that contain plus. So we will derive our a square plus b square from this first identity. Remember, from this thing, if I'm interested in finding a square plus b square, that is, if I'm interested in this, how can I get that? It's simply to make this item here the subject of the formula. So if I make it the subject of the formula, what that means is I will move what I have here into the other side of the equation. There, I can say that a squared plus b squared is equal to a plus b squared minus 2ab. I hope that is taken. So let me go over it once again. What we're actually doing is this expression here, right? So when any expression is of this style or of this pattern, so the concept of dealing with it is what we call the suffix germane, right? So, and by that suffix germane, the very first step is we want to break this thing down into a very simpler structure. So we can see dealing with the power of 4 is too much. it can waste our time, it can create confusion. So whenever we have power of 4, so it is better we break it down to the power of 2. So remember I said it the other time in one of our identities class that when we have a complex power, so what we are going to do is we are going to reduce that complex power to either square identities or to cubic identity. Now that, and what I mean by complex power is whenever the power is beyond cube, when it has a power higher than 3. So once the power is higher than 3, the best way to approach it is what? We break it down into a very simpler simpler power. So, and we can see this one is x raised to power 4. The simpler way by which this thing can be broken down into is by calling it x squared raised to power 2. So x raised to power 4 will be broken down into this form. 4y raised to power 4 can as well be written in this form. We know 2 squared here is the same thing as 4, and y squared, right? Y squared, there is a mistake here. Y squared squared is what I am ought to write here. Remember, this is y raised to power 4, and what I wrote initially is what? Y squared. So, and it has to be y raised to power 4. Even if we try to adjust the question, it must not in any way alter this expression. It must still give the same result as the expression which we are dealing with if you try to expand it again. So it shows that here it will also be this. Remember, square is common to this as well as this. So as a result, I have them in the bracket. So x squared squared is this. Why this one? I will just say 2y squared. So everything raised to power 2. And in order for me to progress with this thing is to try and check this thing. What pattern or structure does this thing resemble from the basic identities that we learned? So we can say it's a case whereby we have our base having the power of 2, another base having the power of what? Having the power of 2. Then, so it shows it is something of this type. And when dealing with something of this type, we now need to recall or to remember from which identity or which identity is this. Do we have definition for this type of identity? And so far so good, all the forms of identity we have talked about is this, this, and this. So do we have any definition for identity by this? So we can see no identity begin with a squared plus b squared. So once nothing begins with a squared plus b squared like this, it shows we should go back into those three identity and try and what? Derive this thing. So where can we derive it? So is it from this, is it from this, or is it from this? But remember, in order not to make mistake, we must make sure that we derive it from the one that contain addition. Reason being that what we are dealing with has addition in between them. So the addition I have in this second one, we should not allow that one to cause a problem for us, right? So it is not the addition here that interests us, but the addition we have in this place or this place. So we now know that a squared plus b squared, right, is the same thing or can be derived as a squared plus b squared is equal to a plus b squared minus 2ab. So having done that, I can now continue with what I have to do. So that now means, remember when we expand this, which is the same thing as this. So it will be equal to expansion of this thing. Remember this thing is the same pattern as this. Remember this is this, right? So when we try to define this identity, so what it means is the first base, right, plus the second base, we are going to square everything. So what is our first base? This is what we are dealing with now. The first base is what I have in the bracket. Second base is what I have in this bracket. So we can say my first base is x squared. So this is what I'm using now. So that would be x squared plus, what is my second base? That is the item in this bracket. We can see it is 2y squared. So there I will say 2y squared, right? After writing, combining the first base and the second base, so I will insert the 2 in brackets, and it must what? Be raised to power 2. Followed by what? Minus. Now the first item after that minus is 2. So I can say 2 times a here means So the first base. So remember the basis item I have in the first bracket. So that would be x squared times b multiplied by b means the second base. That is item I have in the second bracket. The entire item I have in the second bracket. So that will multiply by 2y raised to power 2. So this is the expansion for this thing. So we said this is the expansion for this because this thing is of this pattern, right? So we subjected this thing to this structure. Now from here, now we continue with the manipulation. So in order to manipulate this thing further, so I still have something to clear here. I don't have issue with this. We can say this is x squared plus 2y squared minus. So we can realize what we have here can be written as 4x squared y squared, right? Or since everything is squared, why not write these 2 and 2 here as 2 squared x squared, right? And we can say having 2 square x squared y squared like this makes no much sense. So why not adjust it as, let me write this one the way it is, x squared plus 2y squared minus 2xy everything raised to power 2. So we can see what I have here and what I just wrote has the same meaning. So now when we now observe this thing once again, how do you think we can also continue with this thing? So in order to continue with this thing, we're also going to apply another identity. And out of those 3 identities I wrote the other time, so which of the 3 identities do we think we are going to use? So remember, let me explain it. So it means first base squared minus second base squared. So to me, what it is saying is this is difference of 2 square. This item square minus this item square. Is that not what we call difference of 2 square? That is what we call the difference of 2 square. That is why it is important we don't just memorize in mathematics. We memorize and at the same time understand what we memorized. So that is the only way we can be able to apply it when we have a harder question or something which level of reasoning is somehow high. So we can see this thing calls for difference of 2 square. And how do we use difference of 2 square? Let me write the sample. So if I have a squared minus b squared, right, we know what it means. So let me have it here so as not to. So if I have a squared minus b squared, we know it's going to become a minus b into what? A plus b. So remember, a here means first item, first base, right? While b means the second base. So to continue with this thing, so this thing will become, what is my first base? So first base is x squared plus 2y squared, right? In my structure here, what I have next is minus b. What is b? Second base. So what is my second base? Second base means everything in the second bracket here. So to be minus 2xy. Then we bracket it. So that means we have completed this part. It remains this part. So we are going to open another bracket, right? And that one means a plus b. So remember, you should consider this a to mean the first base in what we are simplifying, and b the second base. So what is my first base? It is x squared plus 2y squared. So that will be x squared plus 2y squared followed by a plus. So I will say plus. Now, what is b? B means my second base. That is item in the second bracket. And that is what? 2xy. Right? So that is the equivalence of Sophie-Germain identity or factorization. So when we have expression of this form, right, it is going to be factorized by Sophie-Germain factorization technique, right? And the result of factorizing this thing is what? Is this. So this is the answer to this thing. I hope that is taken. So so what I will do in this case now is, let me leave you with 2 questions that you are going to work over. So the first one there is p squared, p raised to power 4 rather, plus 4t raised to power 4. And number 2 is m raised to power 4 plus what? 4q raised to power 4. So let's also walk over this in order to really understand what actually happened here. So remember, in the process of doing this thing, two different identities were applied. So the first identity was applied because of the structure here, and the second identity was also applied because of what we have here. So we also should go over this one, and the essence of it is in order for us to be able to fully master and grasp this thing. So shortly we will be moving over to the third factorization technique. Okay, the third one, which may happen to be our last exercise today, our last example today is the one known as FFT. So I think I wrote the full meaning the other time. This means Simon's favorite factorization technique. So that's the one we want to deal with. So that one, when we have question of this form, AB is equal to 3A plus 3B. So it is possible, we all shall soon see that when we break down some complex expression into something of this type. So when we get to this place, we will not be able to continue with the solution. So, and that was my reason for pausing on the identity and quickly come and talk about this factorization technique. So when we understand this factorization technique very well, then we can now go back into the identity. With that, we should be able to tackle any form of identity, right? So now when we have any expression of this form, right, so we cannot use our usual factorization technique, that is those factorization under quadratic equation. It is not enough to do this. So suffix germane 2 cannot be used in solving this. So but what we can use in solving this is what is known as the SFFT. Now, how do we know a question requires SFFT? So one of the elements, right, in this expression will contain those two letters we have here. We can have 3 letters, we can have 4 letters and more than that. But if it is 2 letters, so there is going to be a particular spot there where those A and B or those 2 letters will be combined. And in the other cases, one will take 1 letter, the other one will take the other letter. So when we have expression of this form, then SFFT is the way by which it can be addressed right now. So the first thing is we want to ensure all these variables are gathered in one side of the equation, right? So the first step is to say that AB minus 3A minus 3B, and we know this will be equal to 0. That is the first thing we are going to do. So having done this, now what's the next thing we are going to do? I will consider this and this. So I want to fish out for what is common. So we can see A is here, A is here, right? So that means that becomes A into, what do we have left here? That is B. And what do we have left here? Minus 3. I will now progress with this sign. I will say minus, right? I will now open another bracket like this. Now, because inside this bracket, what I want in this bracket is exactly what is here. So I'm going to write B minus 3, right? But what I have immediately after this minus is 3B and not 3 and not B. How do I now change this B to 3B? So that is by multiplying this B by 3. So it shows 3 will be here, right? So it is still this 3B here. So that is why it is called trick. So this is the trick used by Mr. Simon. So let me say by mathematician Simon. So this is his trick, and it is generally acceptable by the mathematical scholars. So we say 3B, right, minus 3. We are now going to say is equal to We first of all write the 0 here. But when we observe what is here, right, we are going to see or realize that what I have here, right, is not the same thing as what I have here. Now, what I have here is exactly what I have here. But what I have here now is not the same thing as this. And we must make an adjustment. No changes must happen to the expression. Though it is trick we are using. But we must ensure whatever trick we are using does not change the structure or nature of what? Of the expression or the question or the equation which we are given. So as a result, we try to open this bracket. We are not going to write it out, but let's open it by mere looking at it. So, when we open this thing becomes minus 3b plus 9. Remember, minus 3 times b minus 3b, which is the same thing as this. If I now say minus times minus 3, that gives plus 9. So we can see that plus 9 is external or is extra to the main expression I have here, right? So it shows that this thing has increased. In order to adjust it, so that increment has to be removed. The only way to remove it is I will come to this side, right? Exactly what I added to this side, I will also ensure I add it to this side. I hope that is taken. So we can now see this. So this from here now, it now looks like our normal quadratic equation factorization. So here b minus 3 is common. So I will say b minus 3. What do I have here left? A minus 3 is equal to 0 plus 9 here gives 9, and this is the solution. This is the factorization for this expression. Let's take one more question on the use of this SFFT. Okay. I also have this 2ab is equal to 3a plus 4b plus 5. Remember I said the other time that if we have expression of this pattern, what pattern? It's usually three expressions, 3 variables. We usually have 3 variables in such an expression or such an equation, whereby one will contain the 2 letters. Second one, we have one of the letter. Third one, we also have one of the letter, right? So this one is constant. We don't really have issue with constant. We leave constant as it is, right? So when we have something of this, and this type, it shows it is going to be factorized using the SFFT. And how does SFFT work? The first step is we must ensure all the variables we have here, right, are gathered into one side of the equation. Remember I said the variable. So this thing becomes 2ab minus 3a minus 4b is equal to 5. So remember, it is the variables I want to gather to one side, not the constant. So constant will remain in that corner, right? We are now going to factorize. And how do we factorize it? We consider the first two terms, 2ab minus 3a. What is common to that? You can see a is here, a is here. So that will be a into, what do I have here left? That is 2b minus 3. Right? Now, this one is still normal. So then we are now going to use the trick. It is called something trick. So this is the trick part of it. What is the trick? Before we use the trick, let's write the sign we have here, minus. So by his style, he opened this bracket. He said it is equal to 5 here. Okay, don't worry, don't let me introduce this yet. This bracket is opened, Abi. Now, exactly what we have in this bracket, so will be written here. That's the first step to that trick. Then the next is, he now considered what is here. What is this thing? This is 4b. But what do we have here? 2b. How can I make 2b to become 4b? That is by multiplying 2b by 2. 2 times 2 is 4. We just join the b at the back. So it means 2 will be here. Remember, whenever you apply this trick he used, right? So something must have happened to this present expression. So what must have happened? This expression, if you try to open this bracket, right, will be longer than what we have here. It will now contain some extra value. So we now want to have to adjust that extra value out of what we have here. So let me initially say it is equal to 5. Right? We are now going to stylishly open this bracket, but without having cause to write it down. So if I open this bracket, minus 2 times 2b, that gives minus 4b, which is this. Meaning that what I have here, right, contain additional value, which is going to be obtained by multiplying this by this. And what is minus 2 times minus 3? We know that thing is going to be plus 6. So it means what I have here has additional 6. And that additional 6 has to be adjusted. So to adjusting it, so since plus 6 is what I have, so then that means I will also add 6 to what I have in the right hand side of this equation. So from here we are done. We just combine where it is necessary and we give out the final answer. So we just factorize it normally now. So 2b minus 3 is common. So I will write 2b minus 3 into what? What I have here left, a minus 2, we say it is equal to 11. And that is the result for this. So we are going to call it a day there. But let's take one more example on that. We have 4xy is equal to 3x plus 2y. So when we see expression of this form, we know it calls for the application of SFFT. Reason being that one term contains all the letters. Second one will contain one of the letter. Third one will also contain one of the letters. So, and in order to solve it, the first step is we must make sure all the variables are together. So that's going to be 4xy minus 3x minus 2y, we say it is equal to 0, right? So we are going to factorize these first two normally, right? So what is common to this and this? We can see it is x. What do we have left here? 4y minus, what do we have left here? We have 3, right? So the next thing is minus. I will now use the trick, right? It will be equal to 0. So let's use the trick. So what is the first thing in the trick? Is by copying exactly what we have in this bracket here. That will be 4y minus 3, right? Now, but by doing this, we will have extra term. That extra term, when we detect it, we come and put it here. If it is plus, it is addition to everything we have here, it's also going to be addition to this 0. If it is subtraction to everything we have here, it will also be a subtraction to what we have there. All right, but remember, what I have here is not 4y, right? What I have here is 2y. Now, how can I make 4y to becoming 2? So I have 4. I want to adjust it back to 2. So that means that the only way we can achieve that is by dividing it by 2 or by multiplying it by 1 over 2, right? So it means here I'm going to have 1 over 2, right? So I'm going to have 1 over 2. So I will now try to open this bracket. So we'll do well, you can do it somewhere. So minus 1 over 2 times 4y, we know that will give 2y. Minus times minus plus, so that means that thing is addition. So it's going to be addition to, then what is 1 over 2 times 3? You know that gives 3 over 2. We can now say plus 3 over 2. So finally our answer will be written as 4y minus 3 into x minus 1 over 2 is equal to 3 over 2. And this is Simon's favorite factorization trick. So let me stop here. So the splitting method, we are going to do that in the next class, and immediately after it, so we move back into our identity. So I realize it's important we understand the concept before we move ahead to other area of our identity, all because when we continue with the identity and we are here to learn some of these factorization tricks or techniques, so we'll get to a state that we'll not be able to continue. So, and I think it is important as we have just learned it. So we are going to call it a day here. So thanks for watching. So remember to also help to share these videos. So it might be of help to someone. So see, we meet next time. So I say goodbye.